series of forensic science lecture. Today we are going to discuss about serology. Serology is the study of bodily fluids. There are many body fluids which can be found around the crime scene and they can be used for the identification of criminal or the victim. The body fluids include blood, urine, semen, saliva, vaginal fluids, etc. Blood is a very common fluid which can be found on the cases of murder, assault, and semen and vaginal fluids are usually found in the cases of sexual assault, rape, etc. These body fluids, they contain certain antigens or they can be identified using certain chemical tests. So, the study of these bodily fluids is known as serology, which comes under the biology, forensic biology. Now, the first thing, the major fluid which we are going to talk about is blood, the various presumptive tests of blood and the confirmatory test of blood. Whenever we have found any substance on the crime scene and which appears red in color, the first question which comes about is the substance blood? If it is blood, whether this is human blood or animal blood, and if it is human blood, can this particular blood be associated with a particular individual? So, to know whether the substance which we have found at the crime scene is blood or not, we can do certain presumptive tests. One of the presumptive tests is Kastle-Meyer color test, in which other one is phenolphthalein test, where we use hydrogen peroxide and we mix the suspected stain with it. A positive reaction indicated by a deep pink color will tell us whether the substance which is present at the crime scene is blood or not. Apart from the presumptive test, we can also go for certain microscopic analysis. We can prepare the slide and we can look under the microscope whether it is blood or not based on the presence of various RBCs or WBCs, depending upon how old the blood is and how old the blood stain is which we have recovered from the crime scene. Now, the presumptive test or the preliminary test for blood are not definite. If we have to confirm whether the substance is blood or not, we have to go for the confirmatory test after the preliminary test. These testing must be done to determine if the substance is truly blood. Also, there is one important thing to note, that the pink color change which is being produced by the substance which we are assuming to be blood could be a false positive result. So, to confirm whether it is a false positive result or not, we have to go for certain confirmatory test. Apart from the Kastle-Meyer test, we have hemstick test as well as benzidine color test, which are also preliminary or presumptive test. So, hemosticks, it has been found to be very useful by field investigators because it is a deep stick moistened with distilled water, is placed in contact with the suspected blood and a green color change indicates a positive result. Whereas benzidine, which has been used in the previous times a lot by the investigators, but nowadays it is used very less because benzidine is a non-carcinogen. So, for the presumptive test, we can go for the Kastle-Meyer test or hemostic test. Another test which is very important is luminol. The importance of these tests comes even if there is any area where the blood stains might have found or the blood was there, and in order to destroy the crime scene, sometimes the criminal, they remove the blood stains from that particular area. So, let us talk about the example of Arushi murder case. In that case, even we have seen that her bedroom was washed after the blood stains were there. But luminol test is one of the tests where we can identify blood because the substances which are present in blood, when they react with this luminol reagent, they give fluorescence even if the blood is washed out with the water. So, luminol test has an edge where we are looking for the blood over the washed areas, and specifically the washed areas when they are washed with water, in such cases where specifically they are washed to destroy the evidence. This is also a presumptive test for blood, that produces light when it reacts with blood rather than color. So, larger areas can be quickly screened for blood by spraying the luminol reagent on a suspected item or that particular area. So, these sprayed objects, they must be viewed in a darkened area for the emission of light, which we call as luminescence. This is extremely sensitive and it is capable of detecting blood stains that have been diluted up to 3 lakh times. So, that is why when we talk about the washed areas, the luminol reagent works the best. It does not also interfere with the subsequent DNA testing. So, for example, if we are testing with the blood, the same blood can be used for DNA analysis further. So, for identification of blood stains, the early method of detecting blood human stains goes to recognition and characterization of blood stains serve to localize the scene of the crime, aid in determining how it was committed, and if circumstances are favorable, help to identify the perpetrator. So, depending upon if an investigator is visiting a crime scene, he will look for that particular places where the blood evidence is being found. We have to record all the places where the blood has been found. There could be blood found at the crime scene could belong to many different persons or a single person. Depending upon the blood, it could belong to victim as well as it could belong to criminal, or it could belong to multiple victims or multiple criminals. So, whether the blood which is found at different locations, they should be collected separately. We might have to test those blood depending upon the number of people who were involved in the crime, victims as well as criminals. So, the blood stains, how they are located in the crime scene will help us in the reconstruction of the crime. So, at a place where the blood stains were found, so we will get to know whether this is the only primary crime scene or there could be any secondary crime scene. In certain cases, the dead body is being taken from one place to another and you can find blood stains through that particular area. So, that helps us in knowing that the crime has been committed in the first place here and the body has been transferred to another place. So, that is a secondary crime scene. Another important thing when we are talking about the blood stains is the blood spatter analysis, which will help us in knowing from which direction the blood has come and will help us in the reconstruction of the particular crime scene. So, in the year 1900, a series of experiments were run which led to a serum that reacted to the presence of human blood but not to the blood of animals. So, the crime investigator would dissolve blood evidence in salt water and then add the solution to the special serum. This human blood will be darkened by the serum via the precipitation of a protein, and in the year 1904, slaying of 9-year-old Lucy Berlin was the first murder case solved by the amazing new blood detection method. So, this particular method was helping us in even differentiating the blood, the human blood with the animal blood. So, when a darkish substance is found at a crime scene, it must first be determined to be blood using various presumptive tests which are strictly for screening, and that will differentiate between the normal blood and any other color substances or any other food substances which might be getting used up. But if other chemicals are present at the scene to which the test chemicals are sensitive, the test may be vulnerable to corruption. So, for that reason, these tests are done with the great care. A positive result from any of them is an indication that we can go ahead and we can use other tests to confirm. So, any time whenever a blood-like stain is found at the crime scene, there are two basic kind of tests which we usually perform: preliminary test as well as the confirmatory test. If you get a positive result in a preliminary test, then we move ahead to confirmatory test. But if the presumptive test or the preliminary test fails with that red color substance which is found at the crime scene, which assures that this substance is not blood, then we do not have to go further for the confirmatory analysis. The reason beyond the using of the preliminary test is first because they are more cost efficient and they are less cumbersome compared to the confirmatory test. So, what are presumptive tests? Presumptive tests for blood can be found in two broad categories, one that changes color and other that gives a glowing reaction. So, depending upon a color change, it involves various tests, for example, phenolphthalein test, benzidine test, Kastle-Meyer test. The first test is simply the use of a powerful light moved across every surface of a crime scene, which will give us a broad idea where there are possible traces for any evidence. If there is nothing seen, there could be no reason to suspect that blood was present there, and then the presumptive test depends on a color change. If the chemicals are being added and the color is being changed, then we can say that blood is present. Firstly, the Kastle-Meyer color test, where phenolphthalein is the active reagent which is being used in this particular test. When blood is mixed with hydrogen peroxide and phenolphthalein, they are mixed together, it gives rise to a dark pink color. This color change happens because of the hemoglobin, because the hemoglobin is the oxygen containing molecule within the RBCs, which causes a chemical reaction between the hydrogen peroxide and phenolphthalein. So, if the blood is there, the Kastle-Meyer color test will give us a pink color. Another test which is also a presumptive test is leukomalachite green color test. This chemical reagent has been around since the early part of the 20th century and it undergoes a chemical reaction with blood yielding a characteristic green color. So, a pink color is formed in the case of a phenolphthalein test, or we can call it as Kastle-Meyer test, but a green color is formed in leukomalachite green LMG test. Then tetramethyl benzidine test. The suspected blood stains, they are rubbed by filter paper piece and a few drops of tetramethyl benzidine solutions are put over it, followed by hydrogen peroxide, which is H2O2, and if a blue greenish color appears, then it shows that the blood might be present. So, depending upon, we can use any of the three tests as a presumptive test, Kastle-Meyer test, LMG test, or we can use the benzidine test. After the presumptive test, if we have a positive result, then we have to go for confirmatory. If the result is negative after the preliminary test, then there is no point going to the confirmatory test, because if the substance is not blood, then we don't have to confirm anything that whether it is blood or not. Then at the first stage we are clear that apart from blood, any color substance is being used at the crime scene. There are two main important confirmatory tests. The first one is Takayama, other one is Tickman test. Both the tests, they are used in the laboratory very commonly. In this test, we use Takayama reagent and the Tickman reagent. After these reagents are being put over a slide, the crystals appear, which can be further observed under a microscope. A considerable benefit of these tests is that they are more effective with aged stains. So, in both the cases, we have to observe the substance, the blood-like substance, using one drop of these reagents, and then we have to look for the crystals, what kind of crystals are being appeared on the slide. So, the color of dried blood changes in time from red to brown, and the peroxide tests take longer to develop with an old stain. An experienced observer considering these factors might be able to give an opinion about the age of a particular stain, but it is now possible to measure color change scientifically. So, we can go for the spectrophotometric analysis of blood stains, which allows them to be aged within the range of 1 day to 3 weeks. So, whenever the blood stains which are there at the crime scene, and we can look for what is the age of these blood stains using various spectrophotometric techniques. These spectrophotometric techniques, for example, if we are using UV visible spectrophotometer, the OD given by the spectrophotometer will be different for the blood which is a day old and which is a week old or 2 weeks old or 3 weeks old. So, that is how the aging of blood can be done by using the spectrophotometric analysis. There are other tests which depends upon the chemical reaction that causes blood to fluoresce or glow under a UV light, uncovering blood that is invisible to the naked eye. So, as we discussed that sometimes the offenders, they try to scrub walls and floors clean, mistakenly taking for granted that the blood is not visible and it cannot be found. But the first test is simply the use of a powerful light moved across every surface of a crime scene and which will tell us about the possible traces for visible infection. But if nothing is observed with that light, then we can use luminol reagent and we can spray, and the blood, if it is present, even if it is washed off, it will give luminescence that can be observed by switching off the lights and switching on the UV lights. It just take 5 seconds, and the procedure requires that room should be considerably darkened in order to see the faint bluish glow, and the intensity of the glow increases proportionately to the amount of blood present. So, if the amount of blood is very high, the luminescence will be very high, and under the UV light you can also photograph that particular luminescence. The best part is that these tests works even with the old blood or the diluted stains, as we have read that they work even on the diluted stains which are 3 lakh times diluted, and they can even illuminate smear marks where blood has been wiped away. However, there is one problem with this test. Luminol can destroy the properties of the blood that investigators need for further investigation. Therefore, its use is limited to provide that the blood is present even if it is not visible. So, this luminol is a very highly sensitive reagent, and it may reveal that blood is present in minute quantities. Even luminol is able to expose blood in places that have been cleaned repeatedly unless a solvent such as bleach was used. So, if the place is cleaned even 2-3 times using a water, in fact after that the luminol reagent will help us in knowing that some blood was present there. But if a chemical substance is used to clean, for example bleach, etc., then it is difficult for luminol to know whether the blood was present or not. And even on walls that have been painted to hide blood, in spite of the fact that it can negatively impact some serological testing processing, luminol does not affect subsequent blood typing or DNA analysis. So, various other chemical tests can be prevented if we are using luminol, but for the DNA analysis it does not interfere, and we can extract the DNA from the blood which has been tested using luminol reagent. Another reagent which gives tests like luminol is fluorescein. Fluorescein has also been used since the early part of the 20th century. This compound does not interact with bleach the way luminol does. So, the fluorescein is better used over luminol for exposing blood stains that have been cleaned up using solvents such as bleach. So, in certain cases where the surface is being washed using bleach, we can use fluorescein reagent. The fluorescein is advantageous in that it is thicker than luminol and drips less. Therefore, it sticks to vertical surfaces much better than luminol. So, if we have some apprehension that the blood stains might be present on the walls and the blood stains present on the wall are quite thick, then we can use fluorescent reagent, because otherwise if we are using the luminol reagent, it will flow down due to the effect of gravity, but fluorescent reagent will sticks up on the surfaces which are vertical. So, and also fluorescent works whenever the surface is being washed using bleach. So, to know the blood human, we must go for the precipitin test, and this test is based on the theory of antigen antibody reactions. Now, after confirmation of that using various reagent that it is blood, the next question which we are solving is to know whether this blood belongs to human. So, we go for the antigen antibody reactions, precipitin reactions using anti-sera of human, and when we mix it with the blood present, then we get to know whether this is human blood or animal blood. So, if we inject an animal with human blood, the animal will create the antibodies, and that can be recovered and used to test for various human antigens, including human blood antigens. The recovered antibodies are called human antiserum, and to test for human blood, human antiserum and the sample or the unknown blood sample which is found at the crime scene, they are put together. If the blood is human, a precipitate will form using the sample which is found at the crime scene plus the antibodies which we have formed. So, if they will give a precipitin reaction which shows that this blood is human blood. Now, if after knowing this that this particular blood belongs to human, we have to know to whom it belongs. What is the blood group of this person? Can we identify the individual using this blood? For that, we have to go for the abiotyping, enzymes and other factors. So, until the mid 1990s, characterization of blood stains included determining abiotypes, enzyme markers and phosphoglucomatase and other factors. So, before going for the DNA analysis, we go for the abio blood grouping. These tests add statistical information with which to reduce the number of possible sources of the blood stains. Because antigens and enzymes occur independently of one another, the probability of a dried blood stains having a particular combination of these factors is determined by the product of their distribution in the population. So, going for can the blood be associated with a particular individual? So, blood stain found to be of type A. For example, we have done the ABO blood grouping. So, we have found that the blood stain which is found at the crime scene is type A. It belongs to a person who has an A blood group, which means that 42% of population which is A blood group, and we have already eliminated 58% of population. Then next thing is we are going for the stain, for example PGM1, which is present in around 58% of population. So, the combined effect of just these two factors using the product rule is 42% into 58% or 24%. So, clearly if we will add more factors, the smaller the frequency or the occurrence in the population. So, using this methods by taking the ABO blood group, the enzymes, various enzymes, the presence of these enzymes in the particular population will help us in knowing what is the frequency of occurrence in the population. Using this, we can truly associate that whether this particular belongs to a person or not. So, if we have like 5 suspects, then they could be eliminated using all these methods. But for further confirmatory analysis, if we have to stick to it, then we have to go for the DNA analysis for a person identification. Thank you.